Today in class I wanted to get to the elimination method, but I didn't quite make it there with the learning your names and having the visitor from the QSR. So I thought I'd do a quick pencast to walk you through two examples to show you how the elimination method works and to highlight some of the new vocabulary we learned in class today. So first off, I want to find all solutions to the linear system x plus 4y equals 12 and 3x plus 8y equals 4. You'll recognize this from the worksheet we did in class today. So the first step in the elimination method is to start by adding a multiple of one equation to another to eliminate a variable. Alright, so we're going to go ahead and do that. We are going to first eliminate x. So I'm going to take negative 3 times the first equation, so x plus 4y equals 12, multiply the whole thing by 3, and I'm going to add it to 3x plus 8y equals 4. And this isn't really the traditional way that we write these things, so the way that we'll normally write it is I will do it sort of column by column, right? So I'll have 3x minus 12y equals negative 36. That's when I multiplied that first equation, x plus 4y equals 12, by negative 3. And I'll add that to 3x plus 8y equals 4. Okay, and when I do this, the x's cancel, so that's the part where we eliminate x. Eliminate. Okay, and I end up with this new equation, which I'll write in blue. I get negative 4y equals negative 32, and if I simplify that a little bit, I get y equals 8. Okay, so now I have another equation that is consistent with the equations in the linear system I started with, meaning that it has the same solutions. So I have an equivalent system. So I'm going to replace that first equation with y equals 8. So I have y equals 8. And then I have the original, one of the original equations before, so the 3x plus 8y equals 4. Okay, now I want to eliminate y from this equation. I know I can't eliminate x anymore because I only have one equation with an x in it. So I'm only going to be able to eliminate y. And so I'll do this by multiplying that top equation, the equation y equals 8 by negative 8. Okay, and when I do that, now I'm going to have negative 8y minus 64, or sorry, equals negative 64, and the other equation was 3x plus 8y equals 4. Okay, and when I do this, I get an equation. So the y's are going to cancel, right? So we eliminate y. And what I'm left with, I'll do this equation in green, I get 3x equals negative 60, which is the same as x equals negative 20. Okay, so now I have yet another equivalent system. So I have another equivalent system. So I can replace one of those equations from the last one with my equation x, and I'll just 0y, right, is equal to negative 20. Okay, and this actually This is an equivalent system, and because it's an equivalent system, that means that the solutions to this system are exactly the solutions to the original system. And we see that this only has one solution. The unique solution is, well, it's y equals 8, x equals negative 20. Okay, so we found this solution using Gaussian elimination, or just the elimination method.